Yeah, who is stoked about talking CMake? Okay, 2 people. That's more than I was hoping for. Anyways, now this talk is going to be about we in Kokkos have a build and packaging working group. If you didn't know, now you know. And it mostly, I guess, for most users, it flies under the radar, just like when your printer is working, like no one cares. If your printer is not working, hell breaks loose. So first, who is the working group? So there's a bunch of people, a bunch of them are in the Kokkos core team, but we are very proud that we also have people that come from external other projects, most notably Christoph Junghans and Niels and also Richard, who just joined because they think it's an important project. That being said, like right at the beginning, if you are interested in that, if you have problems with build and packaging your application that relies on Kokkos, you can join. It's an open group, everyone can join. If you just want to see how we do packaging, come to our meetings, it's all open. But what do we do? And this is kind of like the one-line mission statement or the focus. We are steadily trying to improve, streamline how Kokkos can be built, packaged, and integrated into projects. But I think it's already, like everything is in the name. It's called the Build and Packaging Group, and therefore this talk will basically take these 2 big chunks, like the building part and the packaging part, and just be structured by these two terms, basically. So what do we do for the Kokkos build system? So first, okay, we try to keep, like Kokkos is using CMake, we deprecated makefiles. We try to keep it up to date. That for CMake is a very long span or large span of things that it could be or could mean, but we try our best. Every so often a new vendor toolchain comes along and that needs to be supported. People want to play around, want to use it, whatever. We try to integrate that into our CMake, so we set the correct flags, everything works. We also are in charge of the documentation of the Kokkos build system. And if the documentation is not enough and you struggle with integrating Kokkos, you hopefully ping us. We come and help you with integrating. And we don't stop there. I mean, that is most of our daily work, but we also try to get a vision. Where should we go in the future? Where should Kokkos build system basically go to? So build systems most of the time are underappreciated. And I think that is especially true for the Kokkos build system. Why? Because if you think about it, it should work reliably and predictably, but for all backends. It's not just someone figured something out that works for his library, for this one compiler, for this one tool chain. It should work for any case you want to target. Otherwise, you would just not be really portable. And that removes a ton of complexity from your desk and puts it onto our desk. It should seamlessly integrate with anything else you want in your HPC code. Like you will probably have not just Kokkos as a dependency. If you do, cool, but you probably have other things. And I mean, we have a combinatoric explosion of tool chains, architectures, operating systems. All of this should just work. And if you think about it, if you integrate Kokkos in your project, you get as a side benefit from apart from having portable code, you get a portable build system and you don't have to do anything for it. And if we wouldn't provide that for you, you would have to do all of that yourself. Like you would have to fiddle around with the flags, the compilers, which of them don't compose, which versions don't want what, and sometimes even the vendors themselves are not really sure which of their things should work or shouldn't. And that boils down to in CMake, if you think about it, it's quite amazing that you can have a portable build system by doing find package Kokkos and then link it to your executable library or whatever, and that's it. That's a huge lift. That's plain vanilla CMake. You don't need any special functions you need to go through. You just do plain vanilla CMake and you get a portable build system for free. So why is this very complex? If we look at this is a very simplified dependency tree. So on the right side, you see there is some user code. It uses some other libs. It uses some stack of stuff, and somewhere there's Kokkos, and we use CMake and into tool chains. Wait, yeah. That is the case where you basically get everything with find package Kokkos, and it still works. If you use Kokkos as we want you to use it, like you use it in your interfaces, you use Kokkos views, you use our main abstractions, then you're probably good with this. That's most of our users. But that's not all. And I want to go into detail on one specific case that popped up, and it popped up in our working group, mainly driven by Richard, and then we went and solved this issue together with the developers of the library. The library is Stanford's Legion, and they have a part that's called Realm. And Realm has a private Kokkos dependence. That means it doesn't expose any Kokkos types in its interfaces. So if you look at their headers, you will never see Kokkos, like a Kokkos object flying around. And they had the problem that if you now have a huge call stack, a huge stack of libraries, and something downstream does not compile with NVCC wrapper, which is our Kokkos internal wrapper for making NVCC basically behave like a C++ compiler. If you have libraries that don't compile with this, you have a problem because CMake only allows you to set compilers globally for the project. And again, Realm doesn't want to go through like special functions, and everyone that depends on them now has to go through special CMake functions to define a target or something. They want everything to look just like plain vanilla CMake because that's what we all would want to go to. So how does this look in the dependency graph? Now just in the middle you have, in blue, you have Realm, and Realm uses Kokkos, but it doesn't want to expose the user code to it. And what happens is if we use NVCC wrapper as your global CXX compiler, remember it has to work on all backends and portably, then because it's a global thing, it affects everything. It affects the user code. It even affects other libraries that you have in your dependency tree. And that's something you don't want. So what we did is we went to the Realm meetings, we discussed with them how to do it, and we basically encapsulated that Kokkos just is inside Realm and it affects Realm itself, but it doesn't necessarily affect user code. Why is it a dashed line this affects there? Because it depends on if you do static or dynamic linking. If you do static, then you still have, at some point you have to link the runtime, and at that point you need the linker that knows which runtime to use. So in this case, there's nothing we can do. It's just how computers work. But we isolated the other libraries that now no longer need to go through, for example, NVCC wrapper in the case of CUDA. But we don't stop there. We went and discussed this problem with CMake. And after some multiple meetings and a lot of brainstorming, we basically got to a point where we have a outline of how we want to do it, and CMake is currently implementing it, how this problem basically gets solved by CMake. So any library that has a private dependency on Kokkos in the future will not just have to propagate something like NVCC wrapper to everything, but it just affects the parts that it needs to affect, which is nice. I mean, previously, we needed to go to every single library that has this problem and try to solve it with them. In the future, this is something that CMake will do for everyone, and not just for NVCC wrapper, but for any wrapper that you would want to use. So in the last year, in the build part, we had these discussions with CMake. It also touches on how does CMake integrate languages. CMake has like CUDA and HIP as a language. they now slowly turned away from that, and that is in part due to the discussions we had with them. As said, we support advanced Kokkos integration. In this case, I showed the realm as an example. But we also affect how Kokkos CMake behaves. So Kokkos now supports multiple CMake languages, meaning you have a Kokkos and you have the backend CUDA enabled. You can compile as CXX if CXX is a CMake language, if your compiler allows it and can compile CUDA with that. But you can use the same Kokkos with CUDA as a language, and that will work seamlessly. And we have a thing that it's a thing of the past, but we are working on deprecating it right now. We misused CMake components for some things they shouldn't be used, and that already affected some users. We are working on yanking that. All right, that was the build part. Now let's go to the packaging part. So the basically founding problem that we had for this working group was the spec recipe. Someone needs to take care of that. So that's one of the main things we do. We keep it up to date. We include new versions. We sometimes fix older versions. We deprecate the ones that are too old. We are currently, or always, trying to simplify the logic inside this spec recipe just for our own sanity, but also it makes it more readable, easy to reason about all these things. You always want things to be simple. For SPAC, we also go and help users that have special SPAC cases that they want to be integrated or they want help with. We are currently discussing a best practices for downstream SPAC packages. This touches mainly on if you are a SPAC package that is dependent on CUDA, should you reiterate options like which backend is enabled and stuff like that? How do you do this? We want this to be kind of streamlined in the whole ecosystem and touching all the packages around that uses. We are also trying to work on getting things that are upstream of us. Kokkos has very little dependencies, but we have two. One of them is MD-span. Now, if you have someone that is using MD-span in SPAC and Kokkos, you would basically get the bundled MD-span and the other MD-span. So we are trying to upstream these things so you can just have a simplified tree and just have one MD-span that you get from SPAC. And we in Kokkos already allow you to use an external MD-span, so most of the build part is already there. We just need to expose this in the SPAC, on the SPAC side. But we also started looking into binary packaging for Kokkos, which is, because of the explosion of architectures and backends and most binary package manager not having a notion of device or any device, basically, it's kind of problematic, but we are looking at it. And if you didn't know, Kokkos has a Godbolt integration, so you can go on godbolt.org. Is it .org or .com? I don't know. I guess it's .org. But you can, in the library tab, you can select Kokkos, and you will get a Kokkos integrated into Godbolt. And it's I guess the developers themselves are the ones that use it the most, because it's super helpful for just quickly looking at, does something work? What does it give me? Where do I end up? So let's look again at the simplified dependency trees, but this time from the viewpoint of packaging. So I hope most of you don't compile CMake from source code and don't compile vendor toolchains from source code, but get them as binaries. And the blue part is basically what we, as a working group, would want to facilitate. If we don't support or we don't provide a binary package of Kokkos, and someone downstream of us, let's say LAMPS, wants to provide a binary package, they would basically have to package us as part of their binary package, which is just awkward. But there are some projects that are doing this, and that's one of the reasons why we think we should basically upstream this, put it onto our table, solve it once, and then basically everyone can just point to that and say, I have this as a dependency. So it's in the early stages. We are closely coordinating with the HPSF binary working group on this, because there's, like, everyone has the questions, how do you integrate a device architecture in binary packaging, for example. And that being said, it's probably gonna start with like just host stuff for now. But I mean, you don't wanna solve everything in a single day. Come on. All right, the second part is the SPAC as currently the most advanced package manager that we use. CMake and the tool chains already have a SPAC package that is not maintained by us. But everything that you see, like the blue span, is basically our own SPAC package, plus any, like with the best practices, like any downstream things that are in the ecosystem. All of this is at least on our radar, and if it's not done by us, we at least try to give you hints, help, whatever, to make this seamless as possible, at least. All right. What are some of the future things that we want to look at in the next time? So we are currently looking at other package managers. There already is, someone did a easy build package for Kokkos. Nick was just finding some free time and built a Conan package for Kokkos. So we are currently looking at these. Most of them have the problem that they don't have any notion of device. So the question is, how do we go forward? For Conan, for example, we try to start a discussion with the Conan developers, how to do this, what would they say, how we want to do this. As said, we coordinate with the binary working group, which is still in the early stages, but how do we create these, the binaries, how do we distribute them? In the community, how do we sign this, all of the stuff that comes that you don't think about, but that's super important. We definitely going to continue the discussion with CMake to create a seamless build system for performance portability. If you think about it, there are other libraries that have the same problem, Q.Thrust, for example, and Sickle. So we're not the only ones, and CMake sees that. We want to have GPU backends on Godbolt. So Godbolt has CUDA integration. So that is the next candidate for, we want a Kokkos CUDA library that you can just select from the library tab. And like CMake 4 did some huge changes. One of them is their package system that they introduced for managing dependencies and for exporting yourself as a package, making that easier, making it all streamlined. So we are looking into how can we benefit from that, how much of our current CMake can we reduce? If we switch that, is it worth it? Like what are cases that are not supported yet in their new specification? As said, like best practices for downstream SPAC recipes. Right now we started with that, but it's gonna be a longer effort because there's a lot of edge cases that are just out there. Another thing is we have TPLs, and Kokkos kernels has a lot of TPLs, and most of these third-party libraries are, someone just came up with how to find them, how to configure them, how to integrate them into Kokkos kernels, and it's just all over the place. We want to make this more streamlined and easier to reason about. And we also we think about if some of us just happen to join other projects or leave, how do we make sure that our next generation can just take off where we left? So for example, we want a checklist. If we have a new Kokkos release, anyone can go to that checklist, tick the boxes, and basically have a full upgraded SPAC recipe, for example, without having to rethink everything. If you want to join, this is part of our kokkos.org webpage where you can find all the details about the working group, the meeting link, who is in there, how to contact us. We have a Slack channel, all of that. And of course, someone paid for it, which none of us gonna read, but yeah, if you want to join, let us know. Thanks.
All right, thanks for the talk. And so we're going to take one question while Bradley is getting set up.
Could you clarify, if I need help for integrating Kokkos, do you actually intend me to join your working group, or do you want me to use the build channel on Slack?
So if it's a simple case, the build channel will probably do it. If it is a complex case like Realm, you might end up in the working group for at least, I mean, you can come to just some meetings, bring up your topic, and then leave again. That's also fine. Anything that makes it easy for you and any way how we can help you, that's fine with us. Please don't send pigeons or something that would be inconvenient, but everything else is literally fine.